Next, we have corrosion. The corrosion, I can say, is nothing but the deterioration, or I can say the destruction of the metal by the redox process, in which the metal get oxidizes in the presence of oxygen and the moisture. Means it's a nothing but the destruction of a metal by the oxidation of metal, by oxidizing a metal in the presence of oxygen and the moisture. Now, whenever we use the word corrosion, the corrosion, due to that corrosion, what happened, that metal get converted into its oxide. As I'm saying that it undergoes oxidation process. But whenever we say it's a corrosion, all the active metals, if I'm talking about the corrosion, approximately all the active metals undergoes corrosion process, like the ions, then silver, copper, aluminium, magnesium, zinc. All the metal undergoes oxidation. All the metal get oxidized in the presence of oxygen and the moisture and get corroded. But when we use the word corrosion, generally the metal which comes into the mind is only the iron atom. Once I said a corrosion, we think about only iron, not about the other metals like the copper, silver, aluminium, zinc, magnesium, etc. Why we always think only about the Fe? Because we had seen in a daily life, we had seen the corrosion, the effect of the corrosion on the effect of a corrosion on the Fe metal, while in case of other metals that corrosion is not observed. But at the same time, if I'm saying that if the silver is losing its luster, that loss of luster is nothing but the corrosion. Silver is having a very large luster, but with the time when we start using it, slowly it loses its luster, and that loss of luster is nothing but the corrosion. If I'm using a copper, slowly, sometime you might have observed that on a copper there is a thin green layer is observed. That formation of green layer on the copper is nothing but the oxide of copper, that is a corrosion has taken place. Now, due to the corrosion, as I said, the destruction, mainly the a big destruction or the big loss is observed in case of Fe, while in case of copper or aluminium, zinc, etc., if the corrosion is taking place and it doesn't produce so much destruction. Now, let's see why the zinc aluminium corrosion does not produce a bigger loss as it is observed in case of Fe, that is iron. Suppose if I'm having this zinc metal, that zinc metal, when it is exposed to the water, or that is oxygen and moisture, they attacks on zinc and they start corrosion. The corrosion, that means they oxidize the surface of a zinc, so that the surface of a zinc get oxidized. That means the corrosion has occurred. But here, after the corrosion, the oxide of a zinc which is formed, that surface on a surface, that metal oxide which has been formed, it is a very tough in nature, or they are very hard in nature. And being a tough or hard in nature, the oxygen and water cannot penetrate this oxide layer. And since oxygen and water cannot penetrate this oxide layer, that's why the inner of the metal which is present below that oxide remains safe, does not undergoes rusting process. So here, in case of the metal like aluminium, zinc, copper, silver, etc., when the rusting takes place, it takes place only on the surface. Once the surface part gets corroded, then the corrosion stops, because oxygen and water corrode, or it oxidizes a metal, not the oxides of a metal. But suppose if I'm having a Fe, what happens in case of Fe? Suppose this is the Fe metal. The oxygen and water will again attack on this and will start oxidizing it. That is, oxide layer is formed, that is called as a rust. It is nothing but the oxide of Fe, that is Fe2O3. So when this attack, this Fe2O3 surface, on this surface get converted into oxide form, that is now Fe2O3 layer has been formed. But Fe2O3 layer, like other oxide, this oxide layer was very hard. But here the Fe2O3 layer, oxide of Fe is not very hard in nature. It's not a very hard in nature. However, I can say that it is a porous in nature. And being a porous in nature, what happened? The oxygen and water enters in the interior part, and slowly they destroy whole metal. And we had seen that rust on the iron metal, and we had seen that it is a porous in nature, and they are very they are not hard in nature, right? So being a porous in nature, what happened? The oxygen and water enters inside also, and they start destroying the whole Fe metal, which doesn't happens in the case of other metals. As I said, the corrosion is nothing but the redox reaction, And since being a redox reaction, it's a spontaneous process also. We never force a metal to undergo corrosion. It takes place by its own. That is, a process is spontaneous. And as I said, it is a spontaneous process and a redox process. So the corrosion, I can say that corrosion or the rusting occurs when a galvanic cell forms on the surface of a metal. Now let's see what happens during the corrosion of iron when the iron undergoes corrosion process. So now this is Fe metal. This is Fe metal, iron rod, I can say. I said that corrosion takes place only when Fe, O2 and water, that is a moisture, everything is present. All three will be there, then only the corrosion will take place. Now suppose on this oxygen, that on this iron rod there is a water droplet. This is the water droplet, that is H2O. And in atmosphere there is a oxygen we have. Now, once a water droplet comes on the surface of this iron rod, I can say that a galvanic cell has been formed. A galvanic cell requires an anode and cathode. So here I can say that whole Fe metal act as an anode. Whole Fe metal act as an anode, except the part which is in the contact with this water and air. It is a cathode. The part of a metal which is in a contact with the oxygen and water is acting as a cathode, while the remaining part of a metal is acting as an anode. We are talking about the Fe. So here Fe is an anode and this oxygen and water part is acting as a cathode. Now let's see what reaction takes place in this case, that is during the corrosion. So the reaction taking place on anode and cathode. Here the anode is Fe metal. So that Fe metal get oxidizes and produces Fe2 plus. It get oxidizes and produces Fe2 plus, that is oxidation. And this is H2O and oxygen both. Then reaction on cathode. The oxygen in the presence of H plus ion. Oxygen in the presence of H plus ion. Now the question arises that from where we got H plus ion, because H plus ion represent the acidic nature. So from where we are getting that acid, because we had considered only three things, that is a metal, O2 and H2O. See the H2O which we had taken, that water droplet, in an atmosphere there is a carbon dioxide gas. So H2 and CO2 reacts together and they produces H2CO3. That H2C, so that acid is nothing but H2CO3, that is a carbonic acid, I can say. So here the O2 in the presence of H plus ion which we are getting from the carbonic acid. Here the Fe2 has lost 2 electrons. So that 2 electrons are gained by this H plus ion and produces H2O. What it produces? H2O. So O2 in the presence of 4H plus ion gain 4 electron and produces 2 H2O. That is reduction. Gain of electron. No, so now let us add both the reactions so that I will get overall reaction. But before the addition, the electron should get cancelled. So here 2, here 4. So multiply this reaction by 2 so that the number of electrons will become equal. So 2 Fe2 plus 4 electrons. So during the addition, the electrons will get cancelled. And we will have 2 Fe plus O2 plus 4H plus gives 2H2O plus Fe2 plus. Here the Fe has been oxidized to Fe2 plus, and I said this is the rust, and in the rust if you will see that Fe is in the oxidation state of that Fe is plus 3. That means Fe, that is an iron metal, get converted into a rust when it get oxidized to Fe3 plus. And here till now only the Fe, that is an iron, has oxidized to the ferrous ion, that is a Fe2 plus ion. And the rusting will start when Fe2 plus will get converted into Fe3 plus. So here the Fe2 plus which is formed, it again undergoes oxidation so that it Fe2 plus get oxidized to Fe3 plus. Fe2 plus get oxidizes to Fe3 plus, that is oxidation. So here I can say that Fe2 plus Again in the presence of O2, that is again I'm writing the same addition reaction. This is now the next reaction which is taking place on anode. To cancel the electron, I will multiply it by 4. So just add, this is anode, the another oxidation reaction taking place on anode and cathode. So 4Fe2 plus O2 plus 4H plus will give 4Fe3 plus and water. The electrons will get cancelled. Now this Fe3 plus and water which has been formed, that Fe3 plus and water, it combines together and produces a rust, that is Fe2O3 and H2O. So this is nothing but the rust, that is the oxide of a iron. So during a corrosion, the Fe produces a rust. The rust is a name of this compound which is formed on the surface. So you can see that a spontaneous reaction is taking place by the formation of a galvanic cell where the whole metal is acting as an anode except the part of a metal which is under the or in the contact with the oxygen and a moisture, which is acting as a cathode. Anode undergoes oxidation, produces electron and get oxidizes to first Fe2 plus, and cathode in O2 get reduced to H2O. But as I said, Fe, if it is in the form of Fe2 plus, will never form a rush. So Fe2 plus again get oxidizes and produces Fe3 plus, and that Fe3 plus combines with the water and produces a rust, that is Fe2O3 and H2O. So in a rust, keep in mind that Fe is always present in +3 oxidation state. So this is about the corrosion of a iron metal. The next is the prevention of the corrosion. As we all know that because of the corrosion, we face a very big loss economically also. So here the corrosion. So there are the various methods which we use for preventing a corrosion. So now let's see those methods which we use for the prevention of corrosion. The first method which we use is coating. Coating method. What we do this, in this a metal surface is coated with some paint, which we generally use in our house, I can say, or it's a normal method which we use. Here the metal surface is coated with the paint, and due to that coating, what happen? The oxygen and moisture do not get into the contact with the means this paint is acting as a barrier between the moisture and the oxygen and the metal. So it is acting as a barrier. But at the same time, I can say that it is not acting as a permanent solution for the corrosion, because once from any point, if that paint layer has been removed or if it got some scratches due to which the paint is removed, then oxygen and water will attack on it, and once the oxygen and water get a chance to oxidize iron metal, then slowly it will enter inside and slowly it will rust the whole metal. That means whole metal will get involved into the rusting or the corrosion process. So I can say that this is not the permanent solution but temporary solution, that coat it. Then second, after coating, the next is a galvanization, which we are learning from a lower standard only. The galvanization, it is a process again like a coating only, but in this coating or here the coating is done by the metal which is having a more tendency to oxidize. For example, suppose again this is the metal, iron metal, which I want to prevent. So here if you want to prevent iron metal, then it is coated with a metal which is having a more tendency to oxidize, means a metal which is having a more SOP value compared to this iron metal. So in this, what happened, that SOP, the metal which is having a higher SOP value is like is converted into a liquid state. That is for example, suppose I can take a zinc. In a galvanization, the Fe is coated with a zinc layer. The zinc is taken in a liquid state and then iron metal is dipped into it, so that the zinc metal, that iron metal get coated with the layer of the zinc, and the zinc being having a higher oxidation potential, that means having a higher tendency to oxidize. The oxygen and water always attack on the zinc only. So here when this metal is kept in a liquid zinc, then liquid zinc get deposited or that metal get coated with the zinc layer, so that oxygen and water attacks on a zinc, and once the oxygen and water attacks on a zinc, so a hard oxide layer of zinc is formed, due to which the inner zinc as well as the metal remains preserved, means it does not get, like here I can say it is one of the permanent solution, because suppose if there is some scratching is also taking place, and if the layer is if that galvanized zinc layer is removed from the surface from any one point, then also the oxygen and water will attack on a zinc only, as the zinc is having a more tendency to oxidize. So it is one of the permanent solution, I can say. The third one which we use is cathodic protection. This is used in those cases where such type of coating is not possible. For example, suppose I just want to preserve, I want to stop the corrosion. I want prevent corrosion. Suppose there is a metal or the metal pipe which is underground, and I want to prevent corrosion of that metal pipe. That metal pipe which is already underground cannot be coated with the help of pent, or here galvanization process cannot be used in that case. So how to prevent that metal pipe? So for preventing that metal pipe, what we do, suppose there is a metal pipe which is underground, which I want to protect. So that metal pipe is connected with the metal. It is connected with the metal with the help of a wire, with the metal like a magnesium. It is magnesium which is having a more tendency to again oxidize. So that iron pipe is connected with the help of a magnesium. So I can say galvanization cell has been formed. Suppose if the oxygen and water is attacking on it, so that Fe will get oxidized to Fe2 plus. Once the Fe2 plus will form, from here the magnesium will release electron, so that Fe2 plus will again get converted into Fe, and magnesium will get oxidized, because if the magnesium and Fe is in a contact with each other, then always the magnesium will oxidize, Fe will not oxidize at all. So Fe will remain in an atomic form. So whatever the effect of oxygen and water is there on Fe will be deflect or will be transferred to the magnesium. So here the magnesium will continuously oxidize, not the Fe. So here, and since as I said Fe plus oxidize, then Fe plus oxidize, then again what the magnesium do, it loses electron, and after gaining that electron, Fe again get reduced. That means again acting as a cathode. So in this galvanization, what we do here, the coating can be done. So a metal which is having a high SOP value can be used for coating. Here the coating is not possible. So we take a metal whose oxidation potential is more, means which have a more tendency to oxidize, because in the corrosion what happen, a metal undergoes oxidation. If you want to prevent the corrosion of Fe, then you have to stop the oxidation of Fe. So here to stop the oxidation of Fe, we are linking it with some other metal which have a more tendency to oxidize. Then fourth method which we use for the prevention of corrosion is passivation. What is passivation? Passivation means it is a process in which the metal surface is deactivated. Suppose it is again a metal surface, that is iron metal. Iron is a highly reactive metal, and that's why the oxygen and water attacks on it and corrode it. So what is done in this case, the oxygen and water can corrode or it can oxidize only to Fe. So and Fe is present on a surface. So here I just want to I want to make that surface passive. So in this case, the metal which is to be protected from the rusting or from the corrosion is treated with some strong oxidizing agent like HNO3. So here the HNO3 is a strong oxidizing agent. So when HNO3 is get into the contact with the iron, HNO3 oxidizes the surface of iron. And due to that surface oxidation, that surface get converted, on the surface we get a thin layer of oxide. Thin layer of oxides of Fe2 plus. That is Fe get oxidizes to Fe2 plus and rust form only in Fe3 plus. So when oxygen and water will come here, it will, instead of getting a Fe metal, it will get the oxides of Fe, and since it will get the oxides of Fe, so it will not attack on it, because the moisture and oxygen will attack only on the metal, and on the surface now currently there is only the oxides of Fe. So the surface has been made passive by treating it with some strong oxidizing acid like HNO3, I can say. Then fifth one, the fifth method which we generally use is alloy formation. We all know that alloy is a mixture of the two or more metals, and sometimes it is done to increase the to change the property of a metal. So here the iron is converted into a steel. By mixing with the nickel, carbon and chromium, it is converted into steel. Iron undergoes a corrosion process, but once it gets converted into steel, the corrosion does not take place. It is non-corroded, right? So Fe can be preserved by converting Fe into some alloys which do not undergo corrosion like steel. So these are the some methods which we use for preventing a corrosion, for the preventing a rusting of a iron metal.